In a world overwhelmed with plastic waste, only 9% of the waste is recycled, a mere 12% is incinerated, while an alarming 71% remains trapped in our landfills and waterways. As time passes, these plastics degrade under sunlight, breaking down into smaller fragments, microplastics. But the threat doesn't stop there.
And when they do so, this can get into the water system. They can also, once they get into the water system, they can get to the fisheries, for example, the species, the aquatic species, or they can also be consumed by human beings. And as a result, they end up harming the body, because these microplastics have been found in other countries. They have been found actually in the human body, meaning that in Kenya, now that we are dealing with prevalent plastic wastes, their chances are that if more research is done, we are likely to be consuming some of these micro and nanoplastics in our bodies. And that's a big issue.
The implications for human health are profound and concerning.
Indeed, microplastics in other countries, other developed countries, they have been found in the fish species. They have also been found in the human blood, meaning that these microplastics were consumed and got into the bloodstream. They have also been found in the human breast milk, as well as in the human placenta. So that tells us that we are actually at risk. As in Kenya here, we're trying to solve this issue, but in other countries, they have already gone into the details of knowing that indeed microplastics and nanoplastics have been harmful to people's health.
But amidst these crises, there is hope. A pioneering research project at the University of Nairobi's Department of Chemistry is turning the tide on plastic waste.
And that's why I come in. That's where the research comes in. Here at the University of Nairobi, I'm working on a RISE-funded project, which involves the generation of low-cost carbon nanoreactors from plastic wastes and their use in monitoring environmental pollutants and nanoplastics. What my research is trying to do is trying to look at a broader picture of this big plastic waste, convert it into a useful product, cheap product, which is affordable energy. As you know, carbon is an inert. It doesn't harm the body. It's not harmful to the environment. So we are converting it into carbon nanomaterials and then using those same nanomaterials now to treat water and also to detect pollutants in the air. So we are solving the issue of plastic pollution, water pollution, and air pollution.
This initiative aims to convert plastic waste into useful, affordable products and also empower the next generation of environmental chemists.
So the Department of Chemistry at the University of Nairobi is very proactive in terms of environment-related projects. And I'm really grateful to the University of Nairobi Department of Chemistry for hosting this project, especially Professor David Karaoke for hosting me in his lab and to carry out this project, because it addresses the issue of environmental pollution. So this is the right place for this project because it has the facilities as well as the manpower in terms of the technical know-how. In addition, in terms of the mentorship, there are students, there are programs in chemistry, that environmental chemistry, for instance, that there are students to work with to mentor in the area of environmental chemistry to be able to impact the society, because we impact the society through capacity development. And for us to do capacity development, that means we need to train students, we need to work with them so that when they go out there, they're able actually to implement it in their various spaces.
Through this research, students at the master's and PhD levels are gaining vital experience, building capacity to tackle environmental challenges head-on.
I'm working on synthesis of carbon materials for application in the treatment of wastewater. The carbon materials, I'm synthesizing them from waste plastic. The one thing that I've learned most from her is how to make good presentation. And then in the write-up of my proposal and even the papers we're working on, she's teaching me how to write papers that can actually be accepted by quality reviewers. She also was very instrumental in writing my proposal, and even when I was going for the presentation to defend my proposal, I was able to defend it without trouble because she had really prepared me. So I'm learning how to present, how to do the write-up, and then even the knowledge on nanotechnology. She's very knowledgeable and she keeps sharing the knowledge with us. I didn't know anything about nanotechnology when I came on board, but by working with her, I can, if you ask me a question, I'm sure I can answer more than I would before I came here. So she's really mentoring us in all aspects, and also she's helping me balance between lab work and my life. Yeah, I've had issues, and when I talk to her, she gives me some pointers or solutions and advice on how I can go about it. So she's not just mentoring me like in the lab, but also about my outside life.
The team is exploring various methods to repurpose plastic waste, from creating construction materials to developing biodegradable alternatives.
All the factories in the western region are around a river where they draw the water from for the production of sugar, and then at the same time they need those rivers because they have to discharge the waste into the rivers. But what I noticed is that the water they discharge in the environment still has the brown color, meaning it's not completely treated. So I thought I can maybe find a way that all that waste from the water can be cleared, so that by the time it is in the environment, it is meeting the discharge standards. It's up to standard before it is released in the environment.
As the University of Nairobi takes the charge, the message is clear. We can turn the tide on plastic pollution. Through innovation, education, and community engagement, we can transform waste into worth, ensuring a healthier planet for generations to come.
In building the capacity and sharing knowledge with the young people, it's a core of value for me, mentorship of the young generation and the students, and also research infrastructure building, not only for the university. And looking at the bigger picture, I'm dreaming of a day that in Kenya we'll have a nanotechnology company that essentially focuses on this area and creates employment for the youth, as well as solves the problems for the community in a biggest picture. And the University of Nairobi being the lead in this, I believe that through the innovations platform, we are able to create innovative products that can be able to impact the society and also develop more curriculums around it. So it's an all-rounded approach. I would like to be very appreciative and thankful for the mentors in my life, because there is no one who can do anything alone. You need mentors, people who have believed in me, people who have given me opportunities. And I would like to appreciate Professor Ngila, my mentor, Professor David Karaoke, my mentor, the staff at the Department of Chemistry, both technical and academic, for the support. Even the students that I mentor, I really want to appreciate them. And the University of Nairobi for giving me a platform to actually do research and teach, as well as innovate new products. And last but not least, I want to thank the ARISE program through the Africa Academy of Science that is supported by the European Commission in partnership with the African Union. I'm really grateful for the funding, because were it not because of this funding, then I would not be able to do what I've done in terms of human capacity building, research development, research infrastructure. I'm very grateful for that, and to Almighty God for the opportunity to be able to do all that I have been able to do.